doesn't matter what you choose. You just want to try to use as much of the graph as you can. All right, so I started both of these things at 0. So I had down here at the bottom I have 0 time, and down here at the bottom I have 0 speed, which is important. And now I need to, figure out what's going on here. So although it doesn't say it in the question, we're going to assume that she starts at 0 speed, because it says she accelerates to 20. So that means she's speeding up to 20, and then she stayed at 20 kilometers an hour for 30 minutes. All right. So she has to start, and then she has to end up at 20. How many minutes do you think it would take you to go from 0 to 20 kilometers an hour on your bike? Would it take a minute? Would it take 2 minutes? Would it take less than a minute? A minute is probably a long time. You think you can accelerate to 20 kilometers an hour? Like, think of a speed zone, school zone, and that's 30 kilometers an hour. If you were pedaling really, really hard, you could probably get there in around a minute or less, let's say. So basically what's going to happen is she's going to get to this 20 really quickly. This first line here is 5 minutes, and this is 10 minutes. So I'm going to assume that it takes her, a minute or less to get to 20. Just a few seconds even, yeah. Once she gets to 20, she stays there for 30 minutes. So this is 30-minute line right here. And it took her just a little bit of time to get to 20. So if she stayed there for 30 minutes, it's just going to be a little bit after that 30-minute line. She's going to be riding her bike at 20. I'm going to connect these with lines for a second. So we'll call this point A, call this point B. So she cycled for 30 minutes at approximately 20. She arrived at the bottom of a hill and her speed decreased to about 5 kilometers per hour. So she got to the hill, and then it decreased to about 5. And that would probably take a little bit of time to slow down. So here's 10. This is 2, 4, 6. So halfway between 4 and 6 is 5. So we'll say that's at about 35 minutes. We'll call that point C. And then decrease to about 5 for 10 minutes. So 35 to 45. She was at 10. And then she cycled up a hill and she stopped for 10 minutes. So if you cycled to the top of a hill, you would probably stop. If you're stopped, your speed is going to be 0. I know I went through kind of some of those points a bit quickly, but hopefully kind of know what's going on. It is really hard to use a tablet and a ruler at the same time. So I apologize if my lines don't exactly meet the points. Draw a line down. Here from C to D, she took a little slow down to 5. This is not working well. So point there, point there. She slowed down again, and then from E to F, she was stopped. Try that one more time. I have a touch screen on my my tablet, and in addition to my touch screen, my hand's on there. And then my actual point where I touch the screen isn't the same as where the line gets drawn, so it's a bit of a mess. And that's kind of where we ended up. Should I use a different color like you did for graphing? No, that's not important. If you have a different color handy and it just makes it easier to kind of see it and recognize it for you, then by all means go ahead and use a different color, but it's not required or anything like that. So we'll just assume you only have a pencil with you, and if you can do it, then just go with it in a pencil. All right, so that's kind of looking at a paragraph and trying to interpret it in terms of a graph, which can be tricky. Usually kind of the opposite of that's a bit easier, where you have a graph and then you try to figure out what's going on the graph. So those are the kinds of ideas that you'll encounter for this sort of first section. I don't think there's anything else here, no. Let's just take a quick look at the learning guide. As I mentioned last day, I kind of butchered the learning guide into two parts. So I just threw the solutions in here for the first couple sections. So how far should we go today? This is kind of looking like stuff we did today. We didn't do relations and functions. So there's two questions for you guys to do for homework. You should be able to do up to the end of page 1. So not a terribly large amount of stuff to cover. So kind of hoping that you guys will be able to get that Unit 4 stuff out of the way tonight. This will take you about maybe 5 minutes, I'm sure, to get through all that. Can we do the first quiz? Yes, you can always do the quizzes. I'm pretty sure I shut off the timers for the quizzes, so we don't have to worry about any of that. And they're open. The course also has a bunch of, I guess we can call them kind of like games. Match the coordinates game. If you go into these things, they give you a little chart, and it asks you to put in some coordinates, and you need to find the coordinates and figure out where 5, 3 is. So we haven't talked a lot about coordinates yet, so just might want to hold off on that. But the other one, it's not what I was hoping for. The match the coordinates game, whack-a-mole, biker graph interpretation. It gives you a link. So what you can do is it gives you a chart. You have distance and time, and then it gives you kind of a section. So from A to B, what's happening, you need to kind of go through all the choices, and then you can just drag it and drop it. And you can put in there, and then you can check it. Sorry, try again. So you can just drag all these things around to try to figure out what's going on in this little picture. So there you go. If you want to kind of play around with those, kind of just a little bit different look at some of these questions instead of just looking at them on paper, a little more interactive. So that's there for you guys to go through. I know somebody at the very beginning of class, I'm going to just scroll back up in my chat, asked a question about Unit 4. And I wanted to get to that. Abby, factoring perfect squares. I don't have a specific question. End of class, one thing I wasn't comfortable with. Okay. So perfect square, I assume, yeah, I'll just find a couple of those to go through. And did anybody have any other questions from Unit 4? Looks like we have about 20 minutes. And I'd be happy to go through anything from Unit 4. I don't have anything else to say about this first lesson, Unit 5, just a bit of a quick one. And Unit 5 should go a little bit faster. The stuff's a little bit more straightforward. I say that, but I know students kind of struggle with graphing sometimes, so I don't want to say, oh, it's easy, and then you get to it and you're like, I don't know what's going on here, and then, you know, I don't want you to feel bad that you don't understand. So generally speaking, the stuff is easier possibly than the other stuff. Students generally do better on this, but if you're having difficulties with it, that's fine. Just ask questions. I mean, we'll get through it together. So difference of squares, I think, is what Abby was asking about. So I'm going to just jump back to Unit 4. Extra practice. I don't think there's difference of squares stuff in here. Maybe I think I did all the difference of squares questions in the learning guide, didn't I? Let's see if I can find them. Somebody asked about these yesterday and I didn't even do them. Factoring perfect squares. Are you talking about difference of squares or are you talking about perfect square trinomials? I just want to make sure we're clear because I don't want to do the wrong stuff. So perfect squares or difference of squares. I see you typing perfect square trinomials. All right, let's look at these. Again, these aren't, I mean, the textbook kind of drew a distinction between these and just regular questions, but there isn't anything special about them other than when you get to the end. I mean, they are easier to factor, but when you get to the end, you're just going to end up with two of the same thing. So let's look at B. I know I already did A. 25 x squared minus 60 xy plus 36 y squared. Now, I guess the trick here is that I can look at this and say, well, there's nothing common to 25, 60, and 36. There's just nothing shared by those things. So I can't factor anything out. So I'm going to take my 25 and multiply it by my 36. I'm going to get a really big number. I don't know what that is. So 25 times 36 gives me 900. So if I do the AC method, just like I'd factor any other question, I get 25 times 36, which gives me 900. I need factors of 900 that add to 60. So I'm thinking 30 times 30 is probably going to be the one I'm working with here. So negative 30 times negative 30, and that's going to add to negative 60. So that's good and that's good. I can break down the middle term, decomposition like I normally would, and I can just do this question like I would do any other question. So 25x squared minus 30xy minus 30xy plus 36y squared. Break it into two parts, factor out anything common. So I get 5x, which leaves me 5x minus 6y. And here I can pull out a 6. Pull out a minus 6 gives me 5x. Oh, I pull a 6y. 5x minus 6y. So I end up with 5x minus 6y and 5x minus 6y, which I can write as 5x minus 6y squared. So the decomposition method that I showed you guys, it works for these. You can look at the question though and say, okay, well my first term's 25x squared, the last term's 36y squared. These are perfect squares. There's an easier way. But I don't think it's worth you guys trying to first look at the question and identify what type it is and go from there. If you can remember factoring by decomposition, one method, as long as there's that number in front of the squared term, that factoring by decomposition will work. It'll work 100% of the time for all factoring questions unless they're perfect square, difference of square ones like the guys down here. So the one method will work always. If you have three terms, if it's factorable, it'll work. So I think that's kind of the important thing. The important thing to remember, there's an easier way to factor perfect square trinomials. You can look at the terms and say it's perfect square. So the first one is going to be 5x, and then the last one is going to be because it's 36y squared, that's the 6y. So if we look at our answer, the 5x and the 6y is the square root of the first and the last term, but it's just, sometimes it can be hard to identify them. So if we can just remember one method of factoring by decomposition, it'll work for 100% of the questions. So instead of remembering different ways for different types of questions, one method for all questions just seemed easier for me. So don't stress out about those types of questions because they're just the same as any other type of question. So there's that. A couple more here. Taylor, should we finish all the quizzes? No, you don't need to finish. Well, you should finish all the quizzes in Unit 4, but not Unit 5. I mean, if you didn't even get to Unit 5 until, tomorrow or the next day, that'd be perfect. It's nothing you need to rush into. Avery is asking page 8-4E. I assume from the learning guide, Avery, you can correct me if I'm wrong. 4E, an expanding question. I did this a long time ago, but it's probably worth doing again because it's a bit of a tricky one. So this might be, unfortunately, all I have time for, but I'll see how fast I can do it. Not that you guys want me to speed through it. I haven't done any expanding questions for a while. And like I was mentioning yesterday, again, it's an important part of the test. So what I'm going to do is I'm going to start with the 4 out front. I'm just going to rewrite it up here so I have some space. All right. So 4x minus 1, x plus 1. I'm going to leave it like that. And then I have this x plus 1 squared, which I'm just going to write as x plus 1 times x plus 1. Okay, there's lots of different ways to do it. You can distribute the 4 through and then FOIL, or you can FOIL and then distribute the 4 through after. I kind of like foiling first and then doing the 4. The important idea here is that the order of multiplication doesn't matter. What's important to recognize is this is a subtraction sign in the middle. So this is a multiplication and this is a multiplication. If I had simple numbers like 2 times 3 times 2, if I go 2 times 3 is 6, and then I'd multiply it by 2, I still end up with 12. I can go 2 times 2 is 4, times 3 is 12. It doesn't matter the order at which you expand, multiply, the order of multiplication doesn't matter is what I'm trying to get at. So what I'm going to do is I'm going to leave the 4 for now, and I'm going to FOIL these things. So first times first is x squared, outside is x, inside is negative x, and last is negative 1. And then I'm going to do the same thing here. I'm going to FOIL first. X times x is x squared, plus x plus 1. Combine like terms. 4x squared. These two guys in the middle actually cancel. This is a difference of squares. If you keep in track, x squared plus 2x plus 1. All right, so now that I have FOILed those, now I need to distribute my number out front. In this case, I have a minus 4 being distributed through my bracket. A little bit messy. X squared times the 2x times the 1. All right, so here I have 4x squared minus 4, and here I have negative 4x squared minus 8x minus 4. Now I can combine like terms. X squared, I have a minus 4 and a minus 4. And then I have this 8x. It's just going to kind of hang along. Nothing I can combine it with. So I have positive 4x squared and minus 4x squared. Those are going to go away. Give me 0. I have this negative 8x, which I'll just drop down from here. And then negative 4 is negative 8. So that one kind of worked out. A lot of things actually canceled out of that one. So if you would have multiplied the 4 through first or the negative 4 in the second set first, you would have ended up at the same spot. So there's more than one way to do it. If order of multiplication doesn't matter, but what's important to remember is the subtraction, that -4 in the middle does. So we're not multiplying the first half of the question here by the second half of the question. Because of this minus sign in the middle, we have to remember that we're subtracting all of the second half from the first half. So I guess that's kind of the important little step there. And Alex put in a comment here, expanding is so much easier than factoring. Yeah, you guys have spent, how much time practicing multiplication all through grade 7, grade 8, even grade 9, you're doing some multiplication with variables. And then, or I shouldn't say multiplication with variables, but multiplication like distributing through a bracket. And then all of a sudden we get to grade 10 and this is the first time you've seen factoring. So you've been seeing multiplication or expanding all through your math careers, but all of a sudden we get to a new idea, factoring, and this is something you've never seen before. So you don't have as much experience with it, but you will. And moving forward in math, you'll have more kind of examples. So Avery, you got that one. Alex, factoring polynomials C and D. This might be the last one. Factoring polynomials. This is like the third or fourth time you guys have asked me about these questions. And I say the same thing over and over again. D is a bit of an exception. It's a tough one. But C isn't. So I look at C and I say, oh, should I distribute this 4 through? No, I don't want to do that. It's not a multiplication question. It's a factoring. Remember, these things are opposite. So I don't want to multiply when something says factor. I want to do the opposite. So I have two terms separated by a minus sign. And I need to figure out what's common to both terms. Now, we talked about factoring just numbers. If I said, okay, if you had something like 12, factor it. Okay, do a factor tree is 4 and 3, and then 4 is 2 and 2. So 2 times 2 times 3 gives me that thing, gives me 12. Well, same deal here with this 4x times 3x minus 1. If I said 4x times 3x minus 1 and I said factor that, okay, what things did you multiply to end up there? Well, if I do a factor tree, I have 4x and 3x minus 1. Those are the two things I've factored to end up there, or two things I've multiplied to end up with 4x times 3x minus 1. I could break this one down further, and 4 times x. I can't break this one down any further though, because it's separated by this minus sign. So I have 4 times x times 3x minus 1. How about the second term is just 3x minus 1? Well, I can't break it down any further. So what do both terms have? Well, this guy here has a 3x minus 1. This guy here has a 3x minus 1. So I can factor it out of both of them. So I pull out a 3x minus 1. What am I left with? So if I look back at the question, what am I left with? Well, I have this 4x here. So I'm going to bring that down, 4x. And what about the second bracket here? Well, in front of this, even though it's not written, I have a minus 1. So I'm going to bring down the minus 1. And that's that guy. This letter D is trickier. You have to break it into two halves, kind of like all of the decomposition questions we've been doing. And think of it as two separate factoring questions. Do the first half, then do the second half. And that will make that guy a little bit easier. How do you know? There's no easy way to tell other than just experience looking at these types of questions a lot. So just kind of one of those things. Just be aware that you might end up with a question like that. 3x minus 1, 4x minus 1. Yes. There we go. That's it for my time, and that's it for you guys' questions. And we did 5.1, so everything I wanted to get through, we're good. Again, if you want to come in today, if you need some help, clarification, just because it's from 1 to 3, if you just have, a couple questions you want to come ask, you don't have to hang around for 2 hours unless you need the help or need to get caught up. So yeah, I'd love to see you guys in here. Everyone's so happy to see students in our building. It's kind of nice, brings some energy to us. So 1 o'clock today would be a great time to come in for some extra help. Hopefully you can get your Unit 4 review in today. I'll get you that password sent out as soon as possible, and then you can move on and write the test either today or tomorrow. That's my goal. Hopefully we can end up with that. So that's it. Thanks, guys. Hopefully I'll see you today. If not, I'll see you tomorrow in class. Bye-bye.